Assalamualaikum and good day. My name is Nurul Nadia Binti Sapri, TC18046, and my partner Farhana Binti Zaimustafa, TC18052.
We would like to present our Senior Design Project 1 entitled Air Stripping as Pre-Treatment Process to Enhance Biogas Production in Anaerobic Digestion of Palm Oil Meal Effluent.
Introduction. Palm oil meal effluent is an underutilized liquid waste stream from palm oil mills that is generated during the palm oil extraction process. It contains 95 to 96% of water, 0.6 to 0.7% of oil, biological oxygen demand (BOD), chemical oxygen demand (COD), and 4 to 5% of total solids, which include 2 to 4% suspended solids. POME is a good source of biogas production that is known as the new prominent renewable energy. For this project, air stripping had been chosen as the pre-treatment to treat the raw POME to increase the production of biogas during the anaerobic digestion process and also to reduce chemical oxygen demand (COD), total suspended solids (TSS), and volatile suspended solid (VSS). Biogas consists mostly of methane and carbon dioxide that has been produced using anaerobic digestion of POME. The process of biogas production involves the indigenous microbial community through hydrolysis, acidogenesis, acetogenesis, and methanogenesis.
Problem statement. Malaysia has emerged as one of the world leading producers and exporters of palm oil products in recent decades. The number of palm oil plants increasing every year, leading to an increase in fresh fruit bunch waste or effluent discharge. Besides, raw POME contain a high concentration of organic materials and residual oil, resulting in a high BOD, COD, high acidic value, high TSS, which can highly polluting wastewater and cannot simply being released to the water stream. Methane release from POME has been one of the most critical sources of global warming. Untreated POME release methane that has 25 times the possibilities for greenhouse gases emissions, which has higher global warming potential compared to the carbon dioxide. And Malaysia currently generates approximately only 2% of its energy from renewable sources compared to the total generation mix, with the only of reaching 20% renewable energy in the energy mix by the year 2025.
Objective. The objective for this project had been separated into two main targets. The first objective is to enhance the production of biogas by providing the best airflow rate and aeration time. The second objective is to enhance the treatability of POME by using the air stripping pre-treatment for an anaerobic digestion system.
Scope of study. This research is conducted to enhance the production of biogas from anaerobic digestion of POME by ammonia removal by using air stripping pre-treatment. For air stripping pre-treatment, it will be conducted with different airflow rate, which are 0.4 liter per minute and 4 liter per minute, and different aeration time, which are 1 to 4 days. Then COD, TSS, and VSS of POME before and after air stripping pre-treatment will be compared. For anaerobic digestion, POME without being treated with air stripping pre-treatment will undergo anaerobic digestion as a control. Then, treated POME will undergo anaerobic digestion process for biogas production. The amount of biogas production will be measured using water displacement method, and the amount of biogas production between control and treated POME will be compared. Literature review. Anaerobic digestion of sludge is the sustainable process producing the energy and minimizing the fossil fuel usage. However, conventional anaerobic digestion of sludge is not suitable since it takes longer time for digestion, which increase the energy input and greenhouse emission. Therefore, pre-treatment technology have emerged to enhance methane production and thus the energy output from the anaerobic digestion process. Pre-treatment technologies adopted mainly physical, chemical, thermal, and other advanced processes to enhance methane production. Type of pre-treatment are thermophilic biohydrogen production, ozonation, acidified process, and air stripping. Among numerous pretreatment processes, air stripping pretreatment has received considerable attention due to the high denitrification rate, versatile operation, and small footprint. Air stripping pilot plants have been used to treat a wide variety of wastewater containing high concentration of ammonia and toxic compounds such as POME.
Anaerobic digestion is a process through which bacteria break down organic matter such as animal manure, wastewater biosolids, and food waste in the absence of oxygen. There are 4 stages involved, which are hydrolysis, acidogenesis, acetogenesis, and methanogenesis, with the presence of their microorganisms for every stage. The organics that feed the anaerobic digestion process are composed of carbon, nitrogen, and oxygen. Microorganisms use those organics as a substrate for growth and combine them with water to form biogas. Anaerobic digestion reduces the volume of the waste, produces biogas for energy, and provides a byproduct that can be used as fertilizer. Proposed design.
For air stripping pretreatment process, aerator and elephant bag will be connected to the glass bottle containing POME using silicone tube.
While for anaerobic digestion process, an elephant bag will be connected to the glass bottle containing POME using silicone tube.
List of materials. These are the materials that will be used in this project. Material for air stripping and anaerobic digestion. Material for chemical oxygen demand test. Material for total suspended solid test. Material for volatile suspended solid test.
Methodology.
The ammonia stripping process is based on the mass transfer principle. It is a process in which wastewater is exposed to air in order to strip any ammonia gas present. In this experiment, sample collected from the anaerobic pond at Felda Lepahile palm oil mill was first tested for its COD, VSS, and TSS. Then, the air stripping process was conducted by filling the glass bottle with 500 ml of raw POME. The glass bottle was then connected with an elephant bag and aerator using silicone tube to supply 0.4 liter per minute of air flow rate during air stripping pretreatment process. The elephant bag is used to trap ammonia gas released from the pretreatment process from escape to the environment. The air stripping pretreatment process will be conducted with 1 to 4 days of hydraulic retention time. After that, the treated POME will be tested for its COD, TSS, and VSS. Then the results of parameter tests before and after air stripping pretreatment process will be compared. The experiment will be conducted with different airflow rate, which is 4 liter per minute.
After the pretreatment of the air stripping process, the bottle will be detached from the aerator. During the detachment, the seal will be tightly closed to prevent any of the gas from coming out of the bottle. The elephant bag attached with a silicone tube will be connected to the treated bottle, replacing the air stripping pretreatment process. The bottle will be sitting around 7 to 14 days and will operate at room temperature, which is around 27 degree to 35 degree for the anaerobic digestion process. Within that time, the elephant bag will be expanded according to the collection of biogas production. Another bottle containing 500 ml of raw POME will be setting in an anaerobic digestion process without the air stripping pre-treatment process, and this bottle will be used as a control bottle. The condition of the anaerobic digestion of the control bottle will be the same as the treated bottle. The biogas collection of the treated POME will be compared with the biogas collection of raw POME. For the final step, all the collected biogas production will be measured by using a conventional method, which is the water displacement method. Theoretical analysis.
POME will be tested for its COD, VSS, and TSS before and after pretreatment. The reading of COD value will be read from the device, while TSS and VSS value will be calculated using following formula.
For water displacement method, the biogas in the elephant bag generated from the glass bottle and collect by filling another container with water. The generated biogas will replace the water by pressing the elephant bag, and water will slowly come out from the container since no element can occupy the same space at the same time. Then the volume of the biogas can be calculated as shown. Expected outcome.
According to Jurczyk et al., in simultaneous stripping of ammonia from leachate, experimental insight and key microbial players, after 1 day of aeration of air stripping at 20 degrees Celsius, COD were reduced by line precipitation, achieving 24 and 47% according to the age of the landfill. Hence, the COD, TSS and VSS removal in this project were predicted to be 24% to 47% since the temperature and aeration times are almost the same.
The amount of biogas production that predicted to be collected is around 55%. This assumption is based on the journal with the title of Biomethane from Palm Oil Mill Effluent POME, Transportation Fuel Potential in Malaysia, written by Muhammad Khairul Ikhwan Sarwani in year 2019 that state, Trap POME through anaerobic digestion produce biogas contain 40% to 70% methane before purified into biomethane for transportation fuel potential. As in fact, composition of biogas are 60% methane and 40% carbon dioxide. So, from this statement, we assume the biogas production that can be obtained later will be around 55% more or less. Cost analysis. The total cost for materials spent in this project are RM445.35.
Gantt chart. This is the Gantt chart for SDP1. It started with the group recruitment on the first week, supervisor approval, project discussion, generate and analyze design, presentation, and end with submission of logbook and final project proposal on week 14.
For SDP2, it started with collection of POME from factory on the first week, conduct parameter tests, air stripping pretreatment process, anaerobic digestion process, and the collection of biogas production estimated to be ended on week 7. Then, the presentation of the project will be on week 12 and final thesis report will be submitted on week 14. That's all from us. Thank you.